Hi, my name is Stein. I'm from the KIT, I'm a student there, and I work together with Benedikt Kämpgen, who was last year here, on the knowledge-based visualizer, a project to visualize semantic relations. What is the motivation? As you might know, Benedikt works heavily on the Searchipedia project. And it's a huge project with a lot of semantic data, with a lot of authors, pages, and triple store, semantic relations. And the question is, when you are administrating a project like this or you're working with it, you have a lot of questions about what ontologies are very widely spread, or who is working on projects and stuff like that. And the data is all in the semantic relations, but it's not very graphically easy to understand for humans. So you can extract it with SPARQL. I think you know that. It's a semantic query language, and then you get by a Virtuoso endpoint or SPARQL endpoint, you get HTML or JSON data, which is the result of your query. What our idea was is we should visualize this data in a very nice way so that humans can see it as a graph. But the very important thing about this is it has to be easy to filter the data, because there are already visualizers out there, and you can visualize all the semantic relations, which easily leads to a big bulk of data which you cannot understand anymore. There are too many lines, too many nodes, too many relations. So the key point is the filtering of the data and the customization of the visualization. That means, for example, color or node size and stuff like that. It must be very customizable for this use case you're using it. So what we did is created a tool, the knowledge-based visualizer, and it uses SPARQL queries to firstly filter the data which is displayed, the nodes and the links, and then also use it to configure how the data is graphically displayed. So you see right here, it's an example. We can say, okay, this node should be red, and this is blue, and you can all do this with SPARQL. You don't have to do anything hard-coded. It's all very flexible. Okay, so there are two SPARQL queries to filter this data, one for nodes and one for links, and all the data is or all the configuration is done by SPARQL variables. So there's nothing, as I said, nothing hard-coded. You just put in the SPARQL query, use defined variables to configure which data is presented and how it is presented. It looks like this. For nodes, you have variables like the title, the shape, the color, the size, and the priority. And for links, it's a little bit less. You can specify, of course, target and source, which has to be there, and the link URI. And the link title you can also control over the SPARQL queries. So a short demo. If you have the question, show all participants connected to the project A01, and mark AIFB participants with a red rectangle, then the query for nodes would be like this. And you see, I can do it with conditions. I can I can set the color variable, or here at this point the shape, sorry, here's the color, depending on semantic relations, completely with SPARQL, so you don't have to do any configuration or anything. So in the next page I show you the result, and it looks like this, because this is all the participants connected to this node, the A01 project, and the red rectangles are the AIFB students, which is done by the conditional queries. It's like the next thing is a little bit more complex, so it's also a demo. I will show it to you live. It's now recursively showing all nodes connected to the A01 project up to 2 levels. And you can also do that with a SPARQL query. I show it to you now. Wait. Yes. Here. This is the tool. You can see here it's a little small screen, I guess, but wait. You can zoom out. Now you see the nodes. I can click on the nodes like this, and it opens in the wiki. And here is the query, SPARQL queries for node query and for link query. And as you see, there are a lot of if conditions and stuff like that to control how the SPARQL query or how the results are displayed. And in this case, I did the convention that if you the center circle should be a rectangle, the yellow circles are 2 on the second recursive level, and the orange rectangles are on the first first level connected. Well, it's just a demo, so you can do all this with this node with a SPARQL query. So the use case would be you have a special question about your semantic data. You develop the SPARQL query for that and use this tool or to display it. And then you can create a permalink to this data, and yeah, well, you can always create the view with actual data without any entering of SPARQL queries. Okay. Okay. Coming to lessons learned. The filtering data and customization is key to using any graphical representation, because otherwise it would be too much data and it would not be useful at all. There's still a lot to do at this point. Even the data or the graphs I created, I think they should be more, even more filterable and stuff like that. You need you get a problem if you have a lot of nodes and a lot of links. One side you have to you have to filter the data in the front end to really see the connections well, and the other thing is that your browser probably will overload at some point, because it's all HTML5 and JavaScript, and it is kind of intensive. Okay, yeah, that's the last point. I was really surprised about that actually, because my laptop is not that bad, but it was very, very fast. If you use a JavaScript framework and it's animated, you can move the dots in the original version. I used VisualRDF as a base for this development, and there you can you can move the dots by drag and drop, and it always recalculates the whole thing, and do that with 100 nodes, and your PC will crash instantly. It's not good. So there are a lot of performance possibilities to improve, I think. Probably it's just not that well coded on the one hand, and on the other hand there are possibility to do that better. Yeah, the current state, it's a functional prototype. It's just an idea. It was a small project I did in a seminar, and I published it on GitHub. So I think it's an interesting idea. I don't know how you really will use it. I think there's a need for usability improvement and performance improvement, and filtering improvement even there. But I think also that it's very important to get use cases on the real cases beside this Searchipedia. Since it's only 2 months or something like that since I published this or finished it, I don't know yet if it's really used in the Searchipedia base. It's published there, but well, I'm not really into that. So I would like also now questions and feedback, or especially use cases where you think something like that could be interesting or could be used, or maybe how it could be improved. Yeah, well, thank you.
Thank you very much. Any questions?
What's the GitHub URL?
What?
The URL to the.
Oh, I can send it to you, but I don't have it here. I wait. It's wait. There it is. This was my first commit, so I hope it's all right.
I think this is especially welcome. That's great. Any other questions, remarks?
I've done some draft visualizations with JavaScript too, and I think the problem with the performance is that the layout has to be calculated by a physics algorithm which is very performance intense, and usually you can't do that in real time. Even
you can't.
Yeah.
Right. Okay.
And even with native programs.
Okay, I didn't know that, but I experienced it that even with not that many nodes, it already crashed. Yeah, it's true. Yes.